right? And remember what the strategy is. The strategy is you take two equations and you pair. For example, I pair number 1 and number 2. For example, this is another student are doing different way. The way the answer is totally regardless the way you decide. For example, I decide take the equation 1 and equation 2 because x is minus x and positive x is ready for elimination. I take advantage. This not always happen in this situation, but in this case, yes, happen. And when you add in by column, this equation, it's obvious that this is cancelled, no? Entonces 6 minus 2 is 4. Negative 3 plus 2 is negative 1 equal negative 5. And this is my equation number 4. Okay. And you now, why not pair another couple? In my paper, I paired 2 and 3. Let me copy 2 and 3. Two. I copy equation 2 again and 3 now. Equation 3. Okay, I can see y is ready for elimination, yes or no? However, this is incorrect because I create this example intentionally to illustrate this idea. If you in the first couple you eliminate x, and the second couple you need to eliminate also x. Okay. Entonces you
Professor, you mute yourself. We can't hear you.
Yeah, I can't hear him either.
get muted.
Okay, you're back.
No, okay. It sometimes happens. I don't know why. I don't know exactly the technical explanation for this. You see the board again? Entonces you multiply by 3. It's minus 3 is 6y minus 6z equal minus 9. No? So the thing I did was I multiplication by negative 3 this entire equation because I want to create negative 3 and positive 3 ready for elimination. And this is cancel good. That was the intention. This is ay. This is minus 2c. Negative 6 and positive 4 and negative, and this is negative 50. And this is my equation number 5. Now I put together 4 and 5. In that moment, we have a system of equations that contain 2 unknowns. It's equation 5, no? And suppose that in this system, I apply one more time elimination, no? I suppose that you multiply by 2, by negative 2. You multiply by negative 2 the equation number 1. When you multiply by negative 2, because I want to eliminate y, maybe, no, it's one intention. Negative ay plus 2c because negative and negative become positive. And here is 10. And this is my new equation 4, is equivalent. Remember, when you multiply one equation by the entire equation, of course, by one number, it is completely depending if it stays. So when you combine 5 and new 4. Let me use in green color. That part is cancelled. Wow, but that part is cancelled. In the right hand side, we have a negative 5. It is a completely false statement. Huh? So what is the interpretation of that? What is the interpretation of that? What do you think about the interpretation? You see before in the last class.
5. 0 equals 5.
Interpretation. Come on. You try to solve the system, but you cannot. And you get completely false statement. What is the interpretation algebraically? What is the interpretation of this?
0 equals negative 5. It's a false statement.
But what is the interpretation of this? Is my question. I saw that this statement is false. Interpretation this. You have no idea. Nobody have idea using the chat. No idea. You are in the last class. Nobody. Nobody.
I was in the last class, but it was.
Sorry. Well, okay. This is the advantage and disadvantage, Joyce, of the online class. Online class, you have to don't be absent any class. Or you watching the video. I posted the video in Blackboard and in YouTube. And YouTube is no update already, but in Blackboard, immediately I finish this, I post it in Blackboard. Because there are no reason. I am absent, but Blackboard is waiting for you. Okay? Entonces, Joyce said, no solution. The interpretation of this is no solution. No solution. No solution is empty set. I suppose in 3D pictures, these triplane never have a common point. Let me try to see in GeoGebra. To curiosity. This is curiosity. Curiosity. Suppose this example. Okay, there you go. Okay, super. Okay, let me try to switch into GeoGebra. Switch into GeoGebra. This is GeoGebra. Okay, remember that some students say, wow, interesting, beautiful. GeoGebra is similar to Desmos, but in 3D. Allow 2D and 3D. This is the axis in 3D. The red one is X, the green one is Y, and the blue is Z. Okay, entonces each equation in 3D is different to 2D. In 2D is a line, in 3D is a plane. This is the plane that represents the first equation. Red color is a plane. This red plane represents the equation 1. This red plane represents blue, represent the equation 2. At least touch intersecting, no? And number green intersecting, but unfortunately, we have no common point in between these. Okay, we have no common point. We have no common point. Look. This is, for example, intersecting is one line. Okay, the black color, you see the intersection between the red and blue. And here you see the intersection between another line. I do 2 new lines to see much better. Let me eliminate the plane. You see this line is the intersecting between 2 planes by pair, but in between have no common point. They are parallel. This does mean that we have no solution. It's clear that no solution. There are no common point in between these 3 planes. Super. Do you understand or you don't understand anything?
I do understand. Yes, sir.
Okay. So I suppose that you are doing better in the test number 2 if you want to improve your grade. Okay, I grade hard is you don't know 0. Okay, you know 100. Okay, let me try another problem. Using the technique que we study here in pre-calculus, no middle school. Okay? Let me go to the one more problem 3D. Que bring me new idea. Suppose this. 2x plus y equal -3. Wow. In this equation, I call number one, the z is missing, okay? And the second equation is 2y plus 16z equal -10. Equation number 2. And the last equation is -7x minus 3y plus 4z equal 8. Equation 2. And this is my system. This is my system. I enclose using this color bracket to indicate that this belongs to the same mathematical object that I want to solve. I need to find the common point. Okay? Okay, the same procedure. I have no idea. You pair two equations. For example, I pair 1 and 3. So I copy 1. I have no idea. We have several ways to do that. I copy the first equation. But I copy the third equation. Okay? Entonces I propose one strategy. One strategy is, for example, si you want to eliminate x, because, okay, you can eliminate x, you can eliminate y, C no, in this case, but you can. Entonces in my paper, I make a decision I want. There are another student doing it in different way, it doesn't change. Eliminate x, entonces I multiply this equation by 7, and this equation by 2. Because I know que 7 times 2 is 14, I know que 2 times -7 is -14. No? So we have the first equation now after the multiplication, hold the equation by 7 is 14x plus 7y equal -21. And this is my same equation 1. It's the same plane. Like when you multiply line or plane 3D, 2D by a number, it's totally dependent. It's the same. Doesn't change. If you multiply by 2, we have -14 x -6y, no? Because it's 2 times -3 plus 8 c equals 16. Because 2 times 8 is 16. Now addition. Addition by column, guys. This is the organization. Okay, I copy. This is equation number 3, exactly the same. You add this. Let me use another color. This is 0. This is y, because 7 minus 6 is 1. I know C have no couple to say bring down is equal -5. And this is my equation 4. Okay? Okay. Now we continue the same. I pair two equations. In my paper, I pair, look at that, I pair 4 and 2, because I take advantage that x is missing in this equation. So I just copy, nothing. This is easier, wow. 2y plus 16z equal -10. And this is my equation 2, remember. I try to manipulate, suppose okay, multiplication by -2, this equation, the equation 4. I multiplication by -2. This is a multiplier. This is a multiplier. This is a multiplier. Entonces, let me see. is, I copy down, minus 2y minus 16z equal negative 10. And this is now my equation number 4, exactly the same. And when you add in this equation, look what happened. Wow, it's a cancel, this is a cancel, this is a cancel. And you get this statement. And this statement is true. What is the meaning of that? What is the meaning of that? What is the interpretation of this? Huh? It's no positive thing. Ah, yeah, you're right. You're right. Yeah, minus times minus is positive. This is the reason that negative thing and positive thing is zero. Okay. Okay, super. Thank you. What is the interpretation of this? Interpretation. 0 equals 0 or 7 equals 7 or 40 equals 40. When you manipulate the system algebraically and you cannot solve it, but you get true statement, it's completely different to the another case that we have false statement. False statement, no solution. But true statement is, you don't know. Nobody know everything. Last class, we studied that. I know that you have no in that class. You absent. Only Joyce, no? Yamil, you are. You were in the last class. A solution, solution. Pero how many? Unique solution or infinity many? Huh? Infinity many solution. We have infinity many solution. Okay. Do you understand this or you don't understand anything? Huh? Infinity, yeah. Many solutions. And leave it like that, no? This is a maybe middle school. But in college algebra and in pre-calculus, we need to represent more clearly. Okay? This is actually is in 3D. Maybe it's a line, maybe it's a plane, but it's infinity, no point. Point is one solution. Entonces you represent like that, look. Solution set, es infinity. Entonces es the triple order because we have 3D, X, Y, Z. Such that, entonces you write, for example, you write this equation. Okay, this equation represents the relationship between Y and Z because you declare one variable free. Suppose I declare que C is free variable. I suppose that the students que are in the last class remember what means to be free. And you put another variable que is X and Y as a function of C get free. C is free. Then it's easy because Y is equal -5 minus AX. Okay, entonces the only thing I need to represent the solution set is discover what is the relationship between X and Z without X. But this is easy because I using, for example, the first equation. It's a similar process to this, similar. Let me copy in the same color. 2x plus y equal -3. I copy the equation 1 again. Yeah, I copy the equation 2. It's 2y plus 16 c equal -10. This is the equation 2, no? And you do something in order to eliminate y. Maybe you multiply the equation number 1 by -2. This is multiply and -2. So when you multiply by -2, we have -4 minus 4x minus 2y equal us the 6, no? Because it's negative times negative become positive. And you adding by column. At the column of the x, we have only one. It stays -4x The column of the y is cancelled. That was the intention, elimination of the y. And the column of the z stay the same, just bring down 16z. And the column of the right-hand side is negative 10 and positive 6 is negative 4. Okay, and this is my new equation. I want to call number 5 equation. Why not? But you can a little bit simplification. If you divide the entire equation by negative 4 in order to simplification a little bit. This is x divided by negative 4. This is 4z. And this is 1. And actually it's the same. This and this is the same, but this is more condensed, more clear. And you solve for x as a function of the independent free variable c, 1 plus 4c. So I am ready to write the final answer. The final answer is separated by comma, x is equal, let me use in black color. Comma, x is equal 1 plus 4c. And close the curly bracket. And this is my famous, beautiful final answer. When you have infinite dimensional solution. That you need to express infinite dimensional solution, but you express it mathematically. Like I said, all the points that belong to this condition and C is totally free. Free, remember, is all real number. No restriction with the C. That is the reason that this represents a line at the intersection. We discovered in the intersection between this equation, okay, each equation one by one alone represent plane is, in this example, a line. Okay, let me try to see this in GeoGebra to understand the geometric interpretation of this. So this is my system. We have 3 equations. We have 3 planes. But I discovered the intersection between these 3 planes. So it's something like that. Let me try to use my skill in drawing. Look, this is a line. We have another plane here. And we have another plane here, maybe. Okay, and this line is the only thing we have in common. One of this segment and this line, because it's infinite in both directions. Okay, it's totally different to the idea for the first example that we have one common point. One common point is suppose, and the example that we are doing last class, we have one plane here. Suppose to make easy, we have another plane here. And we have, wow, one more line. And we have another plane here. A little bit inclination. Entonces, this point is common. No the lines, only one point, unique point. I promise that after I want to show you any possibility. Okay, pero no more GeoGebra. No more GeoGebra. Let's do another more example. Any question in this example? This is hard, I understand. But what is the clue? You don't know anything. You try to do. And in the middle of the process, the algebra indicate you that we have infinite dimensional solution because we cannot solve the system and we get the true statement. However, in order to find this one, okay, you declare one variable free. Normally, the classical variable you declare free always is z. And you try to manipulate in order to express the other variable that is not free, y and x, as a function of c. Okay? Okay. Let me try. Any question, guys? It's clear, confusing? Sorry. It's a pre-calculus. It's not for everyone. Clear. Good. Okay. Only for the student that have a level to take this class and dedicate time with me. That's it. Okay. One new example to illustrate very well this idea of the free variable. Okay. Suppose this example is very, very straightforward. Interesting. Suppose x plus y plus c equal 10. This is my equation 1. 2x plus 2y plus 2c equal 20. This is equation 2. And this is negative 5. X minus 5y. I put elementary minus 5z equal minus 50. This equation. This is my system. I need to solve it. Of course, I don't want to solve it because it's elementary. What's going on in this equation? Suppose they are depending, independent. How you see it depending? Remember, the rule is classical is if you multiply one equation by a number, the new equation that you get is equivalent, right? So if you multiply, for example, the equation number 1 by 2, you get the equation number 2. So you prove que equation number 1 and equation number 2 is the same equation. Si es the same equation, the geometric representation is a plane. So suppose que in black color, this plane represents the equation for the first equation. But the second equation is the same plane because the only thing you should do is multiplication by a number, you have the same plane. And the third equation is also the same because you multiply, if you multiply the first equation by negative 5, we get the third equation. Let me use in another color, maybe green. We discover, too easy, no, I complicate my life. Actually, this system is actually no system, it's only one equation. It's the same plane, it's the same. Entonces, my question is, we have solution, yes or no? Solution, yes or no? No solution or unique solution. Remember, we have in the system, in the linear system of equation, we have only 3 possibilities. One solution, unique, only one. No solution, nothing, or infinity many solutions. What do you think happened in this example? We have solution, yes or no? Question mark. Yes or no? Yes or no? Yes or no? Come on. Yes. Who say that? Who is FB? Opinion. Dice yes. Jeremiah, Vanessa, Steve, Yamil, Deboraine, Christian. No solution. Giovanni say no solution. So we have a competition. The student can believe that we have solution and the student that don't believe we have solution. No solution, yes solution. The rest don't understand anything. Okay. No idea? Well, the answer is yes, we have solution. Explain. Okay, no, but I try. You think about that, no? Of course, we have solution, guys. Okay. Number 1, you understand that equation number 1, equation number 2, and equation number 3 is the same plane. And the question is, there are solution? Yes, we have solution because there are infinity common point in between the black, green, and blue plane. Yes or no? And actually, the solution is this. So the solution is infinity many solution. But it's different to another example because in the another example, the common part in between 3 equations is a line. It will represent in the complicated way solution set. In this case, it's complicated also, but it's different. It's solution set actually is 2D, 2-dimensional figure. It's a plane. In the other case, it was a line. Therefore, we declare two free variables. Entonces, es de triple order again, x, y, z, such that, and we declare two free variables. Why you declare two free variables? Because the solution object, solution space, es obvio que es 2D. In the other example, the solution space was a line, and the line represents one geometric object in 1D, 2 dimensions. In this case, we have 2 dimensions. In this case, we have 1 dimension. That is the reason that we declare two free variables. Entonces, the classical free variable is C and Y. En alfabeto order, pero backward, are free variables. Entonces, in order to express the plane, well, you take the easier equation, because by the way, it's the same. What's the easier equation? My opinion is the first one. And you isolate the remaining variable, is x. And x is equal 10 minus y minus z. That's it. And this is the representation for the solution in this case. Conclusion. When you solve a linear system of equations, it doesn't matter if it's 1 dimension or 2 dimension. We have only 3 possibilities. One solution. When you pair the equation, everything is canceled, nice, and you get x equal 5, y equal 20, z equal 2. It's a 1 point. 1 point in 2 dimension space, or in 3 dimension space, dimension is 0 dimension. We have no possibility to work in. It's 1 point. Unique solution. Another possibility is one line is 1D, and you declare one free variable. And another possibility is the less frequency, never happen, always, seldom happen, que es a solution as a plane, because the 3 equations are completely dependent, and the solution space dimension is 2D. Now we declare two free variables, and you express the remaining variable, que is x, as a function of the free. Okay. This is confusing. I understand very well. Sorry, but I want to present to you, okay, this PowerPoint presentation. In this PowerPoint presentation, you help me to understand the idea of the free variable. Okay, switching to the PowerPoint. Patapum, patapam, show. PowerPoint, slideshow. Okay, boom. Okay, and this is an example, typical example, in which we have one solution. This is geometric interpretation. We have each plane corresponding with the equation. For example, this is equation blue, equation pink, and equation, this is purple, color, whatever, this is blue. It's obvious that in the intersection between 3 planes, we have only 1 point. That's the solution. One solution. This is exactly the same, but with another inclination, no? Red equation, yellow equation, green equation. The solution is this. This is clear, right? How you see algebraically, when you pair the equation and you obtain the equation 5 and 4, and you again solving the system 5 and 4, and you get one solution, 5. Wow, it's one solution. When you get 0 equals 0, infinity minus solution. When you get 0 equals 10, no solution. Let's see this example. We have 3 possibilities, A, B, and C. What do you think? Well, no, si you read English, you understand it's no solution. Why is no solution? It's no solution because we have no common point in between the 3 equations. Maybe we have a common point between the red and the blue. But we have no common point in between the 3 equations. This is typical no solution. So we have different possibilities. It's not too easy. A different possibility. So when you increase in the dimension for the problem, it's more complicated. See, the 4 dimension is more complicated. Go ahead. Come on. Activate the microphone. Speak loudly and clear.
Sorry, I have better internet connection. Can you go back to the last slide,
Yes.
please? Thank you. No, the one. Yeah.
I know.
Okay. Okay. Since nothing is touching, there has no point where they all have point in common. That would mean there is no solution. Correct?
Okay.
By
No,
looking
no,
at a
exactly.
graph.
No, exactly. No, exactly. No, exactly. No, exactly.
Okay.
We can touch, but we need to find touch, o sea, the common point between three equations. Maybe we have common point in between two equations. We have three equations, 3D problem. For example, the one equation is red and another equation is blue, and we have common point. But we have no common in between the three equations, and the red, and the blue, and the purple. Okay? Common point, intersection. They are no common. Do you see or no?
Yes, sir. I do understand.
Eso. Bueno. Let's move on to the next slide. Next slide is a typical infinity many solution. Okay, we have three equations. We have the equation blue, the equation green, and the equation red. And you can see, yeah, this equation share this line common. It's infinity many solution. It's a typical infinity many solution. Do you see or no? Everyone saw? Are you strong or weak to understand this? Strong or weak? Okay, let me see the chat. Okay, we have different examples here. Who helped me with the first one? Solution or no solution? Remember, solution one, infinity or no solution? What do you think about the first one? This one.
Solution.
Come on. Come on.
Solution.
Answer me.
Solution.
Pero how many? One or infinity? This one. Do you see the mouse? The cursor of the mouse moving? Or no? What's going on? Are you there or no? Oh, let me see. Okay. Do you see the PowerPoint or no? Or you are sleeping? Yes, okay. Just answer me. Do you understand, no? So you don't understand and you cannot. Okay. For example, the first one, we have solution, yes or no? Remember, three possibilities.
Yes.
Yes. Infinity solution, or one solution? Infinity solution or one solution? Infinity solution or one solution?
That's infinity.
That's infinity. Very well. What do you think about the second? The second is this. Do you see the cursor mouse moving on the figure?
No solution.
No solution. Very well. What do you think about this? Look at the mouse, the cursor mouse moving on the sketch. What do you think? No solution, one solution, or infinity many solution?
Infinity many solutions.
I don't think so. I suppose there's one solution because the intersection between the red plane, the green plane, and the blue plane is a point. Do you see? It's super clear to see. It's a 1 point in common. Only one, no line, 1 point. Do you see or no? Come on, guy. What happened with the communication today? You have internet or no?
Yes, it just started to rain. I don't know if I'm cutting in and out.
Uh-huh.
It's the microphone. My camera's bad and my microphone's bad. That's not me. I don't know.
Okay. You know, so you have no technical issue to take this class. I understand that you cannot take. You need to take. You have good internet, good computer. Install the software Skype. Okay. One more thing. Okay. Let me try to apply one word problem. one word problem in 2D. In 3D, so. Look. Let me see. Here. So, do you see the PowerPoint or no? Do you see the PowerPoint?
Yes, sir. I see it.
Okay, copy that. It's a word problem. You need to understand it's about money. Money, money, money. I sent to you this PowerPoint, no? So everyone received this PowerPoint or no? Do you receive this PowerPoint or no?
Yes.
Entonces you don't need to copy because you have it in your computer, no? Okay, let me explain. Janet is the name of the one lady. Invested a total of $80,000 in 3 different accounts, mutual funds. She invests in bond fund, it's a name, bond fund, that return 4% in the first year. Basically, we are talking about 1 year. An aggressive growth fund, loss means que es minus, negative. 8% for 1 year. And the international fund is the name of this account, returning 2%. Now, Janet invested $2,000 more in the growth fund than in the other fund, 2 funds combined. Okay, this is a proportion. $2,000 more in the ground fund. Remember, ground fund was the account that have minus 8%. She put more money here que together in the other account. And she had a net loss, the return of the negative $540 in 1 year. How much she invests in each fund. Okay, so this is the problem always to solve the word problem. Sorry, some people say, I don't like the word problem. I don't care if you like or you don't like word problem. You need to learn word problem, okay? Okay, let me put it here. Okay. Switching to the board. Okay. I try to explain how one possibility, no? Because there are infinity possibilities to organization the problem and like a word problem, no? Okay, now for the word problem, I try to set up the equations to characterize the word problem. No? So the first thing you should do is the declaration variable, X, Y, and Z. Okay, X is the account que contain positive 4%. The Y is account que have minus 8. She lost money in this account. And C is the last account que es plus 2%. Okay, entonces I don't care the name, que es international bond. This is the aggressive ground, no sé qué, I don't remember the name. This is the idea. Okay, I rewrite again the problem. Y I read que Janet invested a total. A total is this money plus this money plus this money is equal 88,000. And this is my first equation. Everyone follow me? Everyone follow me with this equation?
Yes, sir.
Say again?
Yes, sir.
Yes, sir. Okay. My second equation, well, is the return. Okay, look at that. Return is, for example, so you express it. This in decimal is 0.04, and decimal is 0.08, and this is 0.02. Pero this is negative, and this is positive, and this is positive. In order to find the return of money, return you multiply the amount of money que you invest, que you don't know. You suppose que es X, ese variable, multiplied by the corresponding percent return, que es 0.04 multiplication of X. This expression alone represents the return in this account. The return in this account is minus 0.08Y, and the return in the last account is plus 0.02C. I hear some noise. Putting off the microphone, please. Good. And the problem say that this is equal negative 540. Okay, because she had a net loss total return. She lost $540. This is my second equation. Everyone is agree with this equation, or you don't understand this equation? Okay? Do you understand or not? Everyone understand this equation?
Yes, sir.
Yes, sir. Okay. And the last equation, the problem say in the one part that Janet invested $2,000 more than so 2,000 more than in this account, Y minus both accounts together is equal 2,000. Do you understand the third equation? Yes. Okay. Yamil Diaz say yes. Okay. Entonces, don't expect that when you set out the equation, you get nice equation. It's horrible equation, but I don't care because I manipulate a little bit in order to express it in elegant way. For example, the first one is elegant, actually. It's X plus Y plus C equal 18,000. This is my first equation, it's elegant. Elegant means express it in standard form. The standard form means that you put one column of the X, one column of the Y, one column of the C, in the right hand side, just a number. This is the elegant. And elegant also is that you never apply decimal, horrible decimal. No good. And this is a little bit more easy. Entonces, in my opinion, you multiply the equation number 2, you multiply it by 100, no? Everything by 100. You know it doesn't affect the answer when you multiply any equation by the number, no? Actually, it's 4. This is 4x minus ay plus 2c is equal minus 54 and 1, 2, and 3, 0. This is my equation 2. Expressed in standard. In my opinion, more elegant to manipulate. Now, well, this third equation is easy because the only thing you should do is apply distribute the property here. This is minus x and minus z equal 2,000. But you write like that? No. Hello. You write like that. You put x in the first column. We reserve one column for the x, one column for the y, in this case positive y, and one column for the z equal 2,000. And this is my equation 3, elegant. And now we start algebra. This is the algebra part. Okay, the process is read the problem, to understand the problem, definition variable. We have 3 accounts. Set out the equation. The first equation was easy because it was the total money. The second equation was a little bit more complicated because it's the return. Okay, and the third equation is the relationship that the problem give me in between the equation that is $2,000 more, right? So you apply the procedure exactly the same that we studied last class, and we applied this class. For example, you pair two equations. So in my paper, I did in that way, guys, sorry. I take the equation 1 and equation 2. I copy again. I want to send the test like that. Organization is important in mathematics because mathematics is disciplined. You are a mess, you are in trouble. Okay, I take the equation 1 and equation 3. Equation 3, no 2. Why? Because I take advantage. Look, equation 3. I take advantage. Okay, X is ready for elimination. Wow, I like that. Choop. And Z is also ready for elimination. This was a coincidence. And this is 2y equal 20,000. And divided by 2, y is $10,000. At least I know in the account of the y, by the way, is the account of the negative 8% rate of return. She invests 10,000. Okay? Okay, but I need to find X and Z, no? So in order to find X and Z, for example, I plug it in the equation number, let me see what equation I use. I use equation 2. Okay, never I touch. So I copy 4x minus, but I know que y is 10,000, entonces multiplication by a is 80,000 plus 2c equal negative 54,000. Entonces I manipulate a little bit, 4x plus 2c. I move y now 80,000 to the right hand side, and you subtracting, when actually 80,000 is positive, minus 54,000 is negative, is 26,000. Yeah, I call equation number 4. Likewise, you take the equation number 1. I like equation number 1 because it's easier. I love you, equation number 1. And then let me change the color. Yeah, I copy in the equation number 1. X plus y, but y I know get 10,000. Plus c I have no idea, equal 18,000. And now x plus z is equal 18,000 minus 10,000. The answer is 8,000. And this is equation 5. And you put y not together, 4 and 5. I just copy 4 again here. 4x plus 2c equal 26,000. It's equation 4, just copy that. In order to apply elimination, I propose you multiplication the equation 5 by negative 2. So multiplication this equation by negative 2. Why? Because negative 2 and negative 2, no. Wait a sec. One detail I forgot. Okay, in this equation number 4, we can divide it by 2. There are many ways. I can see the equation number 4, in order to simplify a little bit, you must divide it by 2 because it's even number. So the equation 4 actually is not like that. It's 2x plus c equal 13. 13, no? 13. You see? Okay, this is this, and this is that. Okay. Ready. Suppose that now, this is equation number 4, but after the division, Suppose they multiply by -1 here. This -1, we have minus 2x minus c. Okay, this line is not good. Look. You put a line when you addition or subtract. Okay, suppose now, in order to elimination, you multiply by -1 here. Why -1? Because it's negative c. So it's negative 2x minus c equal negative 13 times. Now you combine now this equation and this equation together. I ignore this. So we have negative x. This is cancelled. And this is negative 500. No? 500, no, 5,000. Divided by -1 both sides. X is equal 5,000. In order to find z, it's super easy because I know in total. So remember the first equation is x plus y plus c is equal 18,000. I know that this is 5,000. I know that this is 10,000. And have no idea what is c. This and this together is 15,000. And subtraction, 18 minus 15 is 3,000. Easy, complicated, hard. And the homework online, and the test, no. In the test, I don't want to complicate your life with the word problem because it's too hard. Set out the equation. You need to read the problem, you need to understand, and the problem and the test, no. The test not allowed. Test, right, but online, yes. Online, you have a lot of word problem, and you need to work it with. Any question? Do you understand this word problem? What's easy? What's hard? What's complicated? Okay, this is in my opinion, the most complicated part in the test number 2 is the word problem. Word problem in 2D, word problem in 3D. Any question, guys? Having internet issue. Try to get back on. Okay. Who have internet issue? You have internet issue? Remember this is, do you see or no? This is the problem. This is the problem. All right, I speak slow. What's the problem? Internet issue. Do you say? What's the problem? No problem.
Hi, that was me. My internet just flat went out, and I just now got back on. Believe it or not.
Okay. Just in case, remember, we record this, and you can see again if you want, no, to learn. Okay. Any question about the word problem? Do you understand very well or no? Okay. Now we spend the time introduce a new section. It's like an application of the word problem. The word problem, no, the system of equations, sorry. System of equations. Let me try to introduce the idea we spend today and next time doing that part. The name is partial fraction decomposition. Partial fraction decomposition. Okay. What the hell is that? I want to explain in detail now. This is very important. You need to use this in calculus 2. Partial fraction decomposition. Basically, in calculus 2, we working with the one operator is in integral, like that. Boom, integral. Integral in Calculus 2. In Calculus 1 is the introduction, integral. But in Calculus 2, we are doing too hard. Entonces, this operator, suppose you have a complicated fraction, you decomposition in several partial fractions, it's a small fraction, and this small fraction is easy to compute the integral one by one separately. That is the reason it's called a partial fraction decomposition. Let me try to explain the key idea of the partial fraction decomposition using elementary example. I want to complicate the next time I'm using one very hard example. Suppose that we have this example. You have two fractions like that. Yeah, I want to condensing this fraction and this fraction in only one. This is a typical problem of the middle school or the middle school. You find the least common denominator. In this case, the least common denominator is x plus 4, x minus 3, both together. And you divide LCD divided by each denominator one by one, and multiplication by the corresponding numerator. No? And the answer is 3 times x minus 3 plus 2 times x plus 4. I suppose that everyone follow me, no? I suppose that everyone follow me, yes or no? Everyone follow me? Now distribute the property and combine later. This is 3x minus 9. This is 2x plus 8. Denominator stays the same. We combine later. This and this. F5. This and that. And negative 1. Divided by x plus 4, x minus 3. And this expression is equivalent to this expression. But we are doing in this direction. Now, the partial fraction decomposition is completely different. We are doing an opposite direction. Opposite direction. So the expression gets given is this. I want to decompose in 2. The number in the top, I have no idea. I put A and B. When you find A and B, you are doing the decomposition. So in this direction was the classical example in elementary algebra. Now in pre-calculus is different. I have the original fraction, and you decompose into partial fraction decomposition. Okay. I want to solve this problem in 2 different ways. One complicated and one shortcut. The complicated is like that. If you multiply whole thing by the least common denominator, that is this, we have in the left-hand side 5x minus 1 equal a times x minus 3. When you multiply by LCD, that is x plus 4, x minus 3, x plus 4 is cancelled, stay only x minus 3 times a plus b, x plus 4, no? Wow, this is classical in algebra. If you want to eliminate fraction, you multiply the entire equation by the least common denominator. That's it. Now, why not apply distributive property? There's 5x minus 1 is equal to ax minus 3a plus bx plus 4b. And we combine, but we cannot combine because you don't know the number, no? You don't know the number, but okay, I grouping at least like a factorization by grouping. The term can contain x in one side, so a plus b x, and you factor out x. In the other side, when I put minus 3a plus 4b. So we have two polynomials. In the left-hand side, we have 5x minus 1. In the right-hand side, we have a plus bx plus minus 3a plus 4b. This is obvious. You see, should be equal both x because a plus b is 5. And minus 3a plus 4b is equal negative. And just in this moment, we have two equations and two unknowns. And we have a system of equations with linear system of equations with two unknowns. In this case, no x and y, it's a and b, no? You can use elimination, we can use substitution in the paper and doing by elimination, and you multiply by 3 the first equation. This is 3a plus 3b equal 15. So 3 and 5. And ready, this is cancelled. This was intention. This is 7. This is 14 equals 15 minus 1 is 14. Divided by 7 both sides. So we could be 2. I'm going to find a, when I use the easier equation, get the first one. A plus b is equal 5. I know that b is 2. Therefore, a 3. It's exactly the same, the answer we have at the beginning. Look at that, look at that, look at that. A is 3 here. And B was 2. Yes or no? Yes or no?
Yes.
Eh? What happened today? I don't understand anything. When you speak it, I don't hear very well. Yes. Okay. 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 However, I have good news. Good news. Good news is that we have shortcut. Let me try to explain using shortcut. Suppose that we have this situation. Okay, this situation, remember, we get after the multiplication the entire equation by the least common denominator, no? So I propose you one idea. You using a smart value. Using a smart values. What is a smart value? X equal 3. Why is 3 is smart? When you plug in here, 3 minus 3 is 0. It disappears that part. The 3, you replace x for 3. 5 times 3 minus 1 is equal to 8. 3 minus 3 is 0. That's the reason that part disappears. Plus b, 3 plus 4. This is 15 minus 1, 14. This is 7b. Therefore, b is 2. Divided by 7 both sides. B is 2. And we get, look, the same value. Another smart value is x equal negative 4. Why negative 4? When you plug in here negative 4, let me copy again the original expression. Suppose that you replace x for negative 4. So say 5 times negative 4 minus 1 is equal a negative 4 minus 3 plus b, negative 4 plus 4. Negative 4 plus 4 is 0. That part disappears. We have now 20, minus 20, minus 1, and minus 21. And here we have negative 7. Divided by negative 7 both sides. A is equal to positive 2. Exactly the same. This is the best way to perform partial fraction decomposition. But, you say, well, professor, what is the reason that this easy way and you explain me the complicated way? Because not all problems have enough smart value. So we need using the combination of smart value and system of equations. Good or not good? Good or not good? So the next time, next class, we continue to study partial fraction decomposition and more complicated examples. Okay? Enough for today. You can leave only.
I'll look online and watch it online since I missed about 25 minutes. So
Okay.
thank you.
Okay.